Welcome friends to this session of sequence diagrams. In this session we will try to understand basically what are sequence diagrams. We'll go through a fundamental of it, and we will see that how we can use sequence diagrams to express our technical documents, or I'll rather say that what does sequence diagrams helps us to express in technical documents. The first thing is that a sequence diagram gives us two things out. One is that it shows the interaction between objects, and second it shows that how much time is the object alive during that interaction. So in case you think that that your objects is having a lot of interactions, and then your objects are creating and getting destroyed, so the lifetime of the objects are very crucial. At that time you will use sequence diagram. So first thing, ask yourself a question that do I have complicated object interactions, and is the lifetime of the objects fluctuating in a very rapid manner between when the interactions happen. Then you need to use a sequence diagram. If you really see in normal projects, it is not so essential to use sequence diagrams, but what I've seen is that if you draw sequence diagram, if you show sequence diagrams, you get a huge kind of clarity when you talk in terms of interaction between objects. So in the above video you can see that I have shown a sample sequence diagram. Basically we have four objects: customer, product, and stock. So customer queries the request object, customer queries the product object saying he wants to request a product. The product in turn asks the stock object that is this product in stock, and then the stock says okay, yes, this product is in stock or not to the product object, and the product object finally communicates to the customer object. Once the customer object gets a green signal from the product object saying yes, the product is in stock, he requests to make a payment to the payment object, and payment object gives him the receipt back. So what you can see from the diagram is that basically you have interactions, and then these interactions have replies, or you can say you have requests, and then these requests have replies. Now the requests are shown in dark arrow key. So you can see that like the pay money request is shown in dark arrow key, and the return messages are shown in a dotted fashion. So that's one of the important notations we need to follow when we draw a sequence diagram. Second is the boxes. The boxes which we have shown in every object shows the activation time of the object, or shows that what time the objects will be alive. So for example, you can see that the activation of the customer object is for the full time of the message interaction, while the product object and the stock object is probably just at the initial stage when we do the request product interaction, and the payment object is at the last stages. So the payment object is not active when these messages, when you request the product. It's only active when you request the payment, and during the payment interaction, the product and the stock object is not active. So as I said, that you get two kinds of information from sequence diagram. One is interaction between the object, and second is for what period of time is the object alive. So that's the basic way of showing sequence diagrams using UML. So always remember, first show the objects at the top corner in a rectangle with underlined, then show the interaction of the messages, see the lifetime of the objects by using this the rectangle, the activation rectangle, and don't forget that the messages or the request messages are in dark arrow key, and the return messages are in a dashed arrow key. Now we come to the next part, that is the messages in sequence diagrams. As I said, that sequence diagrams is all about interaction. So definitely when we have interaction, we send messages. Now messages come in many formats. There are four kinds of messages which can be represented in sequence diagrams. The first very basic type of message is synchronous and asynchronous messages. So what you do is, again, I've shown object A and object B. I've shown the lifetime activation of objects, and then there are message interactions. Now if you want to show a synchronous message, then you need to represent it by a dark arrow key with a very bold head, with a big arrowhead. So that signifies that it's a synchronous message. Basically, synchronous messages are those messages, where the callee, means the object who is been the caller object, waits until the callee doesn't answer him back. Means what? If the object A sends a message to object B, and until the object B doesn't respond back, the object A will wait for that message to come back. So if the caller waits for the answer, then that is called as a synchronous message. In asynchronous message, the caller just calls the object and goes for doing some other work, and he returns back where he returns back when the callee object tells him okay that he has finished the work. Means what? Object A will call object B for some work, and object B will once he calls, right, he will go to do some other work. When object B finishes that request, he will come back and tell to object A that he has done it. So these are asynchronous messages, and asynchronous messages are represented by thin arrow head. So basically, if it's a synchronous message, you show a dark arrowhead. If it's an asynchronous message, you show a thin arrowhead. The other type of messages which we would like to see in sequence diagram is recursive messages. Sometimes you have huge loops within object itself, or messages interaction, or we can say there are loops where the method calls himself, or the object is calling some functionality himself, the function calling the function himself. So at these kind of in these kind of scenarios, you would need to represent the recursive messages. For example, in the above video we have a maths object, and the maths object is calling a factorial function in a recursive fashion. So what you do is that you show this by using a simple small rectangle inside the big rectangle, and then you show a recursive message interaction. So basically what it says is that it's calling a calculate factorial method recursively until the factorial is not completed. The fourth kind of interaction which you would like to, or the fourth kind of message which you would like to represent in your sequence diagram is conditions. Sometimes you would like that your interaction messages or your message interaction should happen only when certain conditions are fulfilled or certain constraints are fulfilled. So that's shown by using the rectangular brackets. So for example, the customer should call the movie object, the customer object should call the movie object only if the person's age is greater than 10. So he will only call the book, or he will only execute the book tickets interaction if the age is greater than 10. So these kind of messages are where you would like to put in conditions. So that's shown by a rectangle and your if condition. Message branching. Sometimes you want to represent that depending on certain conditions, certain things should happen, and depending on some other conditions, some other things should happen. Means you want to show message branching. So at that time you need to again use the same rectangular brackets, but you need to show bifurcation of message branching by using